What is it? The term DevOps is a combination of the words development and operations. It was coined by two people. Like the origin dates back to 2009 when Patrick Dubois from Belgium and Andrew Schaefer from the US. They got together and they got excited about one presentation that a company called Flickr did. Flickr went to Velocity, that's a conference in 2009, and did this presentation, 10 plus deploys per day, Dev and Ops, Corporation, and Flickr. So if you don't have any experience in software development and release, you might not be impressed. But for those of us who were in the industry at that time, we were just shocked. 10 plus deploys per day. Are you kidding me? Every single deploy is a very, very painful process. How did you do 10 plus deploys? So that was what got Patrick and Andrew excited. Actually, at that time, they were already involved in a movement to bring this agile culture into the infrastructure and also into system administration. So they were very excited about what Flickr was doing. They were very excited about their involvement in this current approach. So they got together, and Patrick organized the first of the DevOps Day in Belgium in 2009. And that's when this term, DevOps, got popularized, because other countries started also to hold this DevOps Day. Okay, so what is DevOps, right? So we have to find a definition for DevOps. DevOps is the practice of operations and development engineers participating together in the entire service lifecycle, from design through the development process to production support. What is this really saying? This is speaking of a way of doing software. Now we learn how to code, but how does that translate into a product for the end user? How do we go through that process? How do we do it? So this is what DevOps is concerned about. So, and as our definition implies, this DevOps movement is advocating that a DevOps team, a DevOps way of doing software, should be involving all the cycle, all the parts of software development. It starts traditionally from the development part, which is code, which includes like a version control, code review. It also should include testing, which usually is relegated to the QA department. But in this DevOps mindset, culture, movement, DevOps teams are responsible also for developing tests, ensuring performance does not degrade, and also managing releases of the software, how the software gets deployed, and also making sure the software, the services are up when customers expect them to be. So what happened, right? We have been doing software fine. Why is that all of a sudden there is this DevOps movement, DevOps culture? Well, so in traditional software development companies, there has been a divide between the development team and the operations team. So this was creating two separate silos within the company. This is at least what was happening in companies in the US. And they realized there was this tension forming between these two parts. For the dev team, we saw ops team as people who were just stifling our urge for innovation and our desire for creativity. So we would develop things and we would send them for deployment, and the ops team would come back to us and tell us, it doesn't work. But then, of course, as a developer, how do you answer that? It works on my machine. So obviously, the problem is with you, ops team. And for the ops team, they just thought that the developers were just, they had no idea how software is really used, really deployed, what are the necessary components to make it work day-to-day, 24/7 for everyone. For the ops team, we think that all code is guilty until proven innocent. Prove to me your code works, and then I will consider putting out for the customer, right? So there was this tension that's definitely palpable in traditional companies. So there was this idea, there was this desire to just integrate those two. Also, this DevOps movement happens, we're going to analyze and try to understand what happened with the software development process that facilitated, that made it easier and made it actually almost natural for this DevOps movement to appear. there were definitely reasons that this movement was able to take hold because it addressed the needs of today's software development. I mean, as a hint, I'm going to tell you, even Microsoft, the people who released software to millions of users using disks, even Microsoft is turning their Office application into an online application. And this is a trend that we'll definitely be able to observe in today's lecture. So, let's talk about software development. Of course, software development goes through these phases we're all aware of. Starts with the requirement, we do a design, we implement, there's testing, comes back, and this circle goes on and on. It all depends a lot of times on how fast this circle goes, right? Back then, when it was mainly mainframes, these were very expensive machines, and coding for mainframes was like a very manual and laborious process. People had to use these punchers that created holes into these cards, and you would have to insert these cards. I don't even want to imagine what would happen if an accident took place, and then the hole, like a new hole came. Like that's a bug in the code. You had to do this process all over again. And something changed when people were able to create an integrated circuit and put a microprocessor in a chip. This allowed the arrival of personal computers. We take personal computers, this term, for granted in today's. You know, everybody has a personal computer or a smartphone. But back then, personal computers was the realm of hobbyists and hackers. Think of today. Suppose you told your friend, I have a personal satellite. Wouldn't that sound like awesome, like cool? That's exactly how it sounded to people back then when they told people, I have a personal computer. Whoa. But then slowly people started writing software for these personal computers, and it started leaving the realm of hobbyists and hackers. VisiCalc was the first popular spreadsheet that was deployed to Apple II computers back then. In 1979, it was the first time people saw that, okay, you have a spreadsheet, you change your numbers here in this field, and suddenly this change propagated to all the other fields. People were really impressed. It really helped them in their business, in their homes. So it was a killer app back then. Sold 700,000 copies in 6 years. People started realizing this software business is business. We can make money out of it, right? And back then, how was this software delivered to the end customers? People had their own personal computers at home. There was no internet, no connectivity, so they shipped, right? You'd either go to the store and bought these disks or tapes, and you loaded the program onto your personal computer. Of course, that created a little bit like, okay, so it means that once the software is out, there's no way to update the software or make changes to it. So how and when do you release a software to the end customer? Do you do it very early, make sure your customer knows that you have the software, but then you may risk having a lot of bugs in the software? Or do you do it later when a lot of your bugs have been worked out, but maybe you're losing market share in the process? So there was this question, right? It has always been the case. Whenever we started deploying software, that we started wondering, when should we deploy? How do we deploy? How do we reach the customers? And back then, of course, because everything was in your local computer, any upgrades, any software that had to be installed, the end user became the system administrator for their home machine. The end user was the one that eventually had to learn what a device driver was, how to write, for those of you who were of that time, autoexec.bat, or config.sys, or config.init files, what those terms meant. Right? It was just very hard. And parallel to that time, people started talking about how do we do software development. One of the first models for software development is Waterfall model. So people start saying, okay, yeah, we should start with the requirements, and once we finalize all the requirements, we go to design, and then the implementation, the verification. Each part was its own separate component. There was a reason to this. If we document every part very accurately, people who leave their jobs and other new team members who come on board, they can just get started. So it's not like out of the world to think of this. This is exactly matches that software development requirements that we've seen before. Why is this called waterfall model? Because ideally, each part is its own finalized product. Once that part is finalized, it moves forward like a water falling from the waterfall. This is actually still existent. I have a coworker in my team. He joined our team like 2014, and he told us that 2 years prior to that, he was working in a company that did waterfall development style. The project was 3 years. By the first year, they worked only on design. There was not a single line of code written. So it still happens. But then something happened. The internet arrived, and with it also World Wide Web. Computers were suddenly connected. Even though your computers at home is your own host, now there was this collection out there. Computers got names. They were given names, and not only just a weird random number as an IP address, but they had their names, and there were protocols specified so they could talk to each other. And more importantly, for us human beings who are much visually oriented, all these mumbo jumbo of letters could be changed to something like this. Very impressive. People liked it. People wanted to use them. And all this was at the fingertips of your web browser. So, of course, there were the browser wars, but they were very popular. They exist in every single machine. Everybody had them. Then people started thinking, if everybody has a web browser, then what if we could run application in the web browser? ViaWeb was one of the first companies to realize this potential. They were later bought by Yahoo, become Yahoo Store. Also, Hotmail was one of the first webmails that came up. So back then, when I first got in touch with email, it was as the mail client from the Unix operating system. Later, it got better. I started using something called Pine, which is a text editor. But I was restricted to the host where my mailbox was. Webmail allowed people to access email everywhere, as long as you had a computer that was attached to the internet. So now that the end user is not running a software that is coming in disks that he needs to upgrade and install its own host, when can you upgrade? How do you upgrade Hotmail? Then, of course, the answer is that you can upgrade anytime. Anytime you want on the server where you are running that specific service. This is actually what the founders of ViaWeb, that later became Yahoo Store, they realized. They realized that they could just do releases whenever they needed to. And they share in their story that they held press releases for we are now releasing version 2.0.0, mainly because back then, people did not understand this concept of server-side software release. And press was impressed when they said, we were doing a major release. But the major release actually had been done many days ago, because they just did it for marketing purpose, because they could just do a release anytime they wanted. And of course, with this paradigm shift, then you don't need so much your computer than access to your data. When I talked to you about the email client that I use called Pine, I had to access the specific server where my mailbox was. But with this webmail access, I could access anywhere. And then, since the service was being hosted by the company owning that service, Microsoft in case of Hotmail, people could access from multiple machines. You would have multiple users, and you became responsible for supporting the number of customers you have. Because it's your program. You have to make sure it's up. And if you have a bug, this bug shows up to all your customer base all at once. And if your server is down, none of your customers can access your service. It is definitely a change in the way that software was being deployed and submitted for the end user to use. Server-based software. Together with this, we also acquired the possibility of seeing exactly what our users were doing. So again, telling the story about ViaWeb, the founder, Paul Graham, he mentioned a specific example. He said that they noticed in their logs that when users were going through their software, there was a point in which everybody, a lot of people, started click on the back button. Everybody, not everybody, but like a lot of people, when they were going through that process, reached a point and they had to hit the back button. So they went back to the original design of the software, and they realized that probably the users were getting confused at that point because their UI was not clear enough. So people had to choose one path and then they had to go back. And once, and he relates that once they fix that UI problem, that back button disappear. That back button event disappear from their logs. We were talking about waterfall models. And people start realizing all different sorts of problems with the waterfall. Well, like, yeah, you can have a design, but like if your project is 3 years, maybe the design that you had in the first year doesn't really fit your needs by the end of the third year. And your customers may come back to you and say, oh, we want more features. And also, by the time you get to the test, you know, it's, maybe there's a problem, you have to go back and change your implementation. So all this call for more agile, which means faster. Let's get a faster cycle. Let's go faster in our interactions. Let's get our customers involved in the development process. Let's ask them, what do you need from this software? What do you want? What do you require from this software? Let's write code, and let's write tests to make sure the code is accurately done. And make sure we don't write what in the US software development called bloatware. Let's make sure we write software that's lean, which means that we address specific needs that our customers want. When we're writing software, it's very easy for us to think, oh, what if our users would need this? What if our users would need that? And we start thinking ways of adding functionality. But one thing that obviously people have realized is the Yagni principle. You ain't gonna need it. So don't write code for that. So this prompted a faster release cycle. Because you were getting more feedback. Feedback came back more frequently. So you added a feature, you saw that it was stable, so you can release it. Now, when are bugs introduced in the software? When there is a change. And the bigger your change set, the more likely that a bug, if introduced, will be there that will be harder for it to catch even. So actually, people realized that if we did more deployments, but each deployment had a smaller change set, that actually led to a smoother experience. We were able to understand what the changes are and filter out the bugs that are come. When we deploy fewer times, but each time a lot of change set, that meant that more bugs could be like inside the change set. Now, look at that. Because it's server-based software, we have to make sure it's up. There is this holy grail in the United States talking about server up 5 nines, 99.999%. That's 5.26 minutes downtime per year. That's the holy grail. We want our softwares up that much. You know, Amazon, it has a cloud services, elastic compute cloud. Do you want to guess what is the availability that Amazon promises? Any guess? 90%? Huh? Oh no, 5 nines is the holy grail. They didn't get there, but it's definitely higher than 90%. It is actually 99.95%. So somewhere between 8.76 hours and 52 hours. So around maybe 3 or 4 hours downtime per year. That's how much Amazon is promising you. And if you read their service level agreement, you will find that they give you credit if they fail this service agreement. That's actually the push. That's how much you need to compete in today's world. Because if you cannot promise to your clients you are up by that much, then why would they go with you and not go with Amazon? Right? So we saw that the software part, the development part is adopting this agile procedure. But then we saw the requirements, the needs for this high availability as we are transitioning into this server-based software. But in the deployment pipeline, actually, the change had not reached there yet. People were still doing manual deploys. People were still very, very, very much involved in their own servers. Actually, back then, servers were pets, right? They were given names. A sysadmin would go in, handcraft some shell script to make sure it's correct. And if they got sick, if they are failing, you had to nurse it back to health, make sure it's healthy. This kind of model, so if you want to improve the performance of your server in this kind of model in which servers are pets, it meant that you bought more hardware. You bought faster processors, you got more RAM, you got more disks. So, what we call scale up, which is like a vertical scaling approach. But that was easy when you didn't have that many hosts. This is a sketch of the precursor to the internet, which is the ARPANET in 1969. Back then, you could count in your hand the number of hosts that people were thinking. But look at this. In 2005, this is a map of the routes in the internet. If you need to start attending to this kind of scale, you cannot afford to do handcraft your servers. And look at this projection. This is exponential in a scale, right? So like logarithmic scale. So we're predicting 1 billion connected devices. And if we're talking about Internet of Things, when small devices attached to your home may be connected to the internet, then you are just talking about so many devices that can be attached. How can you scale to meet this kind of service? Yeah, exactly. Cloud arrived. We are no longer restricted to the realm of physical hosts, but we are talking about virtual hosts that can be spun up very quickly. What is the cloud? Convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. In my company, back then when we did not have the cloud, you send in a request for a physical server. The request might be fulfilled like 2 months later. But currently, since we are going to the cloud, I'm given permissions to access the cloud, and I can spin up a virtual machine in a matter of minutes. And that's how fast I can create machines to attend the needs of my service. Amazon Web Service is definitely the leader in this market. It started with 2006 with their Elastic Compute Cloud service. And once they opened this market, people saw the potential, and people started using it. CERN, a European Organization for Nuclear Research, excuse me, they were talking about 27 petabytes of data each year to be saved for 20 years. And by 2014, they already had 100 petabytes of data, and they expect 400 petabytes annually. They, of course, didn't go to Amazon Web Services. It's too expensive, I guess, for them. But they started using something called OpenStack. When people saw how Amazon Web Service was able to make money out of these cloud services, people started realizing, oh, wow, maybe we are missing the boat. So many companies got together, and they started this OpenStack initiative, which created this software layer that you could put on top of your hardware resources. And this layer would give you the capacity to create virtual machines. And this is what OpenStack is. And when I wrote this slide, so back then, CERN had already 120,000 cores and expecting to be a lot more. And definitely, cloud computing is here to stay. There's no way around it. I mean, physical hardware is necessary. You create these big racks of data, but it's the cloud computing, the layer that will abstract your hardware resources through which you will interact with this physical layer. The IT spending increased from is estimated to increase to 11% in 2018. So what happens? Servers could no longer be pets. They became cattle. They are no longer given names. They're given numbers. And they're thought to be identical. And if one of them is failing, unhealthy, what did you do? You didn't nurse it back to health. You just kill it and spin up a new one. That's actually the approach that our cloud team tells us when we deploy. We tell them, okay, I'm having problem with this VM, seems unresponsive. They just tell us, you know what, you just kill it and create a new one. If you're killing and create a new one, you cannot afford to go manually and then go manually configure it all over again. It's impossible. You cannot do that. And with this approach, you cannot, I mean, of course, you're limited. Your OpenStack layer maybe give you the maximum of 16 cores and 32 gigabytes of RAM. So how can you increase capacity? Your applications have to be written such a way they can scale horizontally. You add another server, you can add more capacity. That's what we should aim for. So we can see that there is another arrival of the cloud. Servers can come up. So there's a need for us to extend this Agile infrastructure, Agile sysadmin, to the deployment part as well. So what does the pipeline look like? So we talked about this historical movement towards server-based software. Yeah, and I cited it as indication that even Microsoft is going to this cloud-based subscription business model. They are the king of the disks, right, for their Microsoft Office products, downloads, and nowadays they're even going to, these days they're going to the subscribed model, which is server-based software. So, and then of course the cloud, and then all this like a push toward this movement. So I'm going to talk now about what would a DevOps pipeline for software development look like. How do you do it? How do you minimize the risks of introducing a bug? How do you make sure that your software can be deployed? So what are the tools that you need? So our team, the team that I work with, we do DevOps. So we realize that you see this fast feedback, right? This is the insight that Agile gave us. This fast feedback is necessary at the team level. Make sure everyone in your team knows what's going on. And any change must be communicated and reviewed. It may sound very, very obvious in the beginning, but if you have done extensive software development, you might realize that it's very easy for you to be focused on your own development work and miss out completely on what your colleagues are doing. And likewise, they may be so focused on what they're doing that they don't even know what you are trying to accomplish. So in order to fight against this tendency of creating these smaller groups, whenever we have a project, we divide our work into sprints. Sprints are 2-week-long times. At the beginning of the sprint, we come together, we plan what we need to do. The project's divided into the product owner and technical team. The product owner is the one that will tell the technical team, what are the features that I want from this product? And that's it. That's the only thing he says. I want this feature and I want this priority. The technical team is the one that is responsible for taking the whatever the product owner said and go and work on it. At the end of the 2 week, we have a retro and we tell, okay, what worked and what didn't. And on a daily basis, we meet for stand-up meetings. Stand-up meetings means that you should be very fast, 15 minutes. Everybody just go around and say what you worked yesterday, what you plan to work today, and what is blocking your current work. If you have a blocker, you should let everybody in the team know, because then the team can help you. That's actually very efficient, really. It helps you be focused. It helps you to make progress. It helps you not to be lost and trying to figure out things. And when the team is working, we use a visual aid to help us track work. We borrow this technique from Kanban, and then which essentially means that you create cards, and then you track your work by cards. Now, how do we do this really? We don't use paper. We use something called Slack for communications. I mean, I encourage you to get used to it because it's definitely a very, very popular tool that everybody is using. Not everybody, but a lot of people are using. It actually groups communication channels by topic instead of by people. Oftentimes when we communicate, we like to think of, oh, this group of people should be included in this message. But actually, in Slack, they abstract this concept and they say, okay, let's create a channel for this topic. And people can just join as they wish if it's a public channel. This actually helps when you are managing multiple projects because you can just go and join as you need. And also Slack is integrated with other products. These days, you cannot really do anything in isolation. Everything is integrated. So Slack, for instance, is integrated to Trello, is integrated to many other things that I don't even use too, but it's integrated to Trello, which is the board application that we use to track our work. We essentially divide the work into smaller cards, and each card goes into a specific column. You can organize, say, your board like this. So there's some request, something that's backed up, something that you're working, which is in progress. There's something that's in review, that's to be deployed, and something that you already deployed. Right? This actually helps you focus. Say you limit. So you limit the number of cards that can be in progress. What does that do to your team? If I'm working, and I say, okay, only 3 cards can be in progress. And already 3 cards are there. So if I see that, I cannot pull another card and work on something else. I have to go and join somebody who is already working one of the cards and join their work. That actually helps the team become focused. You really work only on what you need to work on. So this is how we communicate and how we track work. It allows us to see, if you open the Trello board, you know exactly where your project is. So that actually helps in your understanding of where each part fits together, how you should do your own development. But when it comes down to code development, you need something that allows you to do version control, and you need something that allows you to do code review. So we use GitHub, the Git model, and we use the GitHub pull request model. How does that work? We have one account, which is the master. It will hold the master code repository. Every member of the team forks the master into his or her own account in GitHub. So I create a fork, and then I pull down my repository into my laptop or my workstation, and I start work. Once I finish my change, when I finish my code, I do a commit and push back my code to my repository in GitHub. And then I do a pull request. Essentially, I tell the owner of the master account, okay, I have something and I want to merge into your account. And GitHub is set up such that whenever you're sending a pull request, it automatically creates for you a change set file. You can see exactly what the changes are there, what you're trying to do. And this is very important so that your team members can see what you are trying to do. In our team, code can only be merged into master when it has been reviewed by at least 2 developers. 2 people have to give you a thumbs up to say, okay, I like what you did, I agree with what you did. So there are cases in which people will say, I don't think this should be in the master. And then you see, this forces developers to talk. You have to talk, you have to reach consensus, you have to understand what you're doing. People can comment, people can give suggestions, and once everything is finalized, it's merged to master. And every team member should just grab a new copy of the master, like do an update and grab a fresh copy, the latest updates from the master. So this is code review. And code that has been reviewed has to be tested. Now, as developers, we may feel like, I have to run a test and wait for the test to run. It's time-consuming, pointless. Agreed. Definitely, as developers, you shouldn't waste your time running and waiting for tests. So there was one developer, he wrote in his book that he actually is the one that usually broke the build, right? Because he probably skipped a step. He merged before testing, and the build broke. You couldn't build anymore. So he wrote a special software called Jenkins. Jenkins is this this specific server that can get the change set you want to implement, run the test for you, and it's integrated with GitHub. So you can tell GitHub, is this change set, did this change set break anything? If it didn't break anything, it allows GitHub to merge. But if it did break something, then it will prevent GitHub from allowing to merge. So this is very easy, right? So as a developer, you write a code and submit a pull request, and then you just wait for the Jenkins to tell you, can you merge or can you not merge? This process is called continuous integration, which means that as you try to integrate every time you're running, your test. So only when it's fully integrated can you merge. Then, of course, it's always possible. What happens if the developer says, oh, but it works on my machine, right? I see. So anybody want to take a guess and how you can address this issue with some technology that's already prevalent today? You can use something called Vagrant. It is exactly spin up a virtual machine with the specific OS and capability you want. There's something called Docker that at another presentation somebody suggested. It's also possible, slightly different, but Vagrant is very good. It essentially allows you to spin up a virtual machine using a text as configuration. What this means is that it makes it easy for you to spin up one. You can spin up different Vagrant machines that matches your deployment environment and test your code using those. And now that you have your code ready and tested, now we need to, so this part, right? So this part is all ready. We have make sure, we already reviewed our changes. We made sure that they pass our test. Now we have to talk about this. So I talked to you about OpenStack, the cloud development. We no longer push our code binary direct to a physical server. What we do, we put down this layer, OpenStack, on top of our physical servers. And this OpenStack, it has different components. Nova is the one that will allow us to spin up virtual machines. Say, I want a virtual machine with 4 CPUs, 4 gigabytes of RAM, 20 of disks. Fine, it will do it for you. I want 16 vCPUs, 32 gigabytes of RAM, or 200 gigabytes of mounted disk. It will do for you. Right? So this is what the power of OpenStack allows you to do. You can create just these VMs. And you can create as many as you want. But then, again, these are cattle. You cannot afford to go one by one. So what have people come up with? People have come up with configuration management software. Anybody has heard of Puppet? Chef? Ansible? No? Yeah. So this is something that's happening with the infrastructure team. One of the earliest configuration management software is called CF Engine. After CF, it was created by some system administrator that was frustrated that their machines were just, he had to go manually inside each machine and change, and if he missed one change, then the machine was broken, and he had no idea which one broke. So he created something called CF Engine. People realized it's really good. And then later there was a product called Puppet that came up, and Chef. And now the one that we are using is called Ansible. Ansible allows us to create in a text file, in essentially a YAML syntax, a sequence of configuration events we want the server to have. So we tell the server, oh, download this YAML package, and then install and start running this service, create this file, create this directory. And once you have that playbook, you can run that playbook across different servers, and all the servers will have the same configuration guaranteed, right? So you don't miss anything, and everything is fine. The advantage of Ansible, as we see it, over Puppet is that Ansible allows orchestration. Puppet and CF Engine are declarative state configuration management engines. What does that mean? It means that you declare the final state you want your host to have, and Puppet and CF Engine, they try to figure out how to do it. But in Ansible, it allows you to orchestrate. So you tell this server come up first, this server come up second, first one talks to the second respond. It allows you to tell the different hosts what they need to do. And this sequence repeats itself every time you run the playbook. There is no room for a human failure error in that sense. Or at least we try to minimize human failure in that sense. So when you combine Ansible and OpenStack, Ansible has modules that interact with OpenStack. So you can just leverage the power of Ansible module and use that to bring up machines in OpenStack. So in a cloud-based environment, you run Ansible playbooks. So we do that. So in our service, we develop a key value store on our cloud-based service. We spin up, if the data center is empty, right? So we don't have any service there. We run our playbook. We spin up front-end load balancers, our API layer service nodes, and our React nodes for back-end storage. Like we have like about 60 hosts that we spin up, and the Ansible Playbook configure each one of them, and it's all done in a matter of like hours because we just launch it, and then we can just watch. We don't have to do anything. Like 60-some hosts in a matter of hours, and we are working to reduce that deployment time. So that's how people deploy. But of course, now that it's deployed, we have to remember, we are to make sure that it's up and running. So what do we use? It's kind of hard to see, but we use a tool called Dynatrace. This is proprietary, and it's a paid service. It allows us to set up alerts. But there are open source tools available. Riemann is a tool written by a person called by the nickname of Afir. He wrote a series of blog posts called Jepson, who studied distributed systems. So he wrote this Riemann tool that allows you to send alerts. And Graphite you can use to store the data that Riemann sends and visualize. And now we're talking about these servers that are running on the cloud, and I told you that we have 60 hosts, right? Now what happens if something happens? There's a problem. These servers are still spinning out like logs. How do you look at your logs? When this cloud deployment service started, people realized that this was an issue. You cannot SSH into every single server and look at their logs. It's just impossible. So they developed a product called Splunk. This is, again, paid product, but does log aggregation. The open source equivalent is the Elk Stack, which E for Elasticsearch, L for Logstash, and K for Kibana. 3 products, they integrated in Logstash. It can actually give you the power of Splunk. Of course, you have to manage your own Elk Stack, but it allows you to have the power to Splunk. Splunk allows you to create dashboards. You can see the performance as told you by your own logs. So that's very reassuring. Dynatrace can give you real time, and Splunk can confirm what Dynatrace is telling you. So this is our pipeline. So we have stakeholders, people who are interested in our product. They can see the advance of work in Trello. They can check the conditions of our service in Splunk and Dynatrace. We have the development team communicates to each other using Slack. We ensure that we remove the change environment via Vagrant, and our code that we develop, it goes into GitHub. GitHub is integrated with Jenkins. Jenkins runs the test, makes sure that all our code passes, and Jenkins can also run the Ansible playbooks for us. So if we give Jenkins the power to run the Ansible playbooks, it can actually detect if a merge happens to our master repository. Once a merge happens to our master repository, a trigger is sent to run the Ansible playbook, and this Ansible playbook deploys our software to OpenStack. This is called, if this is all automated, it's the pipeline called continuous delivery. It means that all our changes with the push of a button can just go right to our customers, right in front of them. So if, as a developer, if I'm running, I write a chain set, I submit it, and 2 people give me the thumbs up. Then I press the button to merge, then it's out there. People will see it. That's continuous delivery. Then becomes a question, right? DevOps team. We manage, we code, we monitor. So are we developers or are we operators? In the traditional software development company, developers are allowed to go home after 6 p.m. and forget about their product. You don't have to worry about them. But as part of the DevOps team, I cannot. I have to be available 24/7, so we have an on-call schedule. Every member of the team that I work with, we are on call. We have 2 on-call engineers all the time. So you have to make sure you're available. PagerDuty is what we use to send text alerts to us. But we're not operators. We can add features when our customers tell us, when we see things. So it's definitely DevOps. It's neither operator nor developer. It's both operator and developer. So if this is the current state of affairs for software development, then what are some of the things that may come up next? Remember in the beginning when there was no internet, software was sent to their homes, right, via disks, and the end user had to administer them, install, become the sysadmin. Nowadays, more and more, we see the appearance of smart devices. We have this Nest, which is the smart thermostat. It controls your temperature automatically and smartly, in a sense. You have these smart light bulbs that can turn on and down as when you come in the room or can you go out. All these things are showing up in our customers' houses. So I work for a cable company. We have a set-top box that has to be installed in our customers' homes. And this set-top box can integrate with many these smart devices. It can integrate with the light bulbs. It can integrate with thermostats. It can integrate with locks, smart locks, garage door openers. So you have, and then people have to start using them. And then nowadays, people use something called if this, then that, ITTT. So end users are starting to integrating these services. Well, wow, there is an opportunity, right? End users shouldn't need to do that. How do we apply this concept and help our customers to just automatically do this? Maybe we can do it for them, right? DevOps at home for the Internet of Things. And then also, more and more systems, you see this explosion, right? Systems are becoming so complicated. You have this huge complex system. And so far, everything has been always only maybe on the software development side. But who is using these services? Human beings. There's a growing field of research and studies that's called human factors engineering. How do we integrate humans in these systems that we are writing, that we are integrating, that we are developing? And of course, with all that I told you, there's definitely a clear change in the workforce characteristics that we are seeing today. It's very customary in the morning. When I go to work, I check my Slack, and it's very common. People will tell me WFO. A team member will come to Slack and say WFO. What does that mean? Work from office. He's announcing to the team that he will be working in the office today. And equally as likely, every day, when I go and check my Slack in the morning, somebody may be posting WFH. What does that mean? Work from home. Yeah, my coworker's working from home. We have 2 remote team members. I'm based in Philadelphia, the east coast of the United States. I have a team member that is based in California. We have our daily stand-up meetings in 11:30 to sort of, get somewhere so that we can accommodate the time zone difference. And I have another remote worker, a colleague. He was hired when he was working in, I think, Arkansas, and he relocated to, I think, Kentucky or vice versa. I don't remember. But that's it. To me, there was no difference. He moved physically, but to me, he was just there virtually. I have another coworker who told us, our family is gonna relocate from Philadelphia to Minneapolis. In the old days, what would that have meant? He probably would have to look for a job in Minneapolis. But these days, he told us, I will be staying with the team. Yeah, our manager really liked him. He's definitely a very good engineer. And we can work like this, right? So we're working from anywhere. And as we are working from anywhere, as we are integrating this way, it's also become customary in our Slack channels. They're working from home for a reason, right? So some other people say, okay, I'll be offline for 2 hours because I have to go get a haircut. It happens. Or say the coworker that's relocating, I have an agent coming to my home. I'll be offline for 2 hours because I have to show him the house. It happens because that's how things are. It's like as if you were in the office, but you have to step out for an errand. It's the same. So this is happening. All these tools, right, DevOps, allows me to work from home. Then, of course, it means that I have to be available from home anytime. So I can be working from anywhere. I can be working actually from Georgia if it's really necessary. I made sure I was not on call this week, but otherwise, yeah, I could be working from here. So that's the change that we're seeing. DevOps is just one movement about software development and delivery that is a reflection of all these trends that we're seeing in the industry. So I would like to conclude and give thanks for International Black Sea University for inviting us here and for City of Hope for arranging this lecture series.